everyone, welcome back to my channel. In today's video we'll see how to optimize cost for Google Kubernetes Engine. So this is a challenge lab and you get 1 hour 30 minutes to complete this challenge lab. So let's go through the challenge scenario before starting the lab. So you have been given a task to deploy your application onto Google Kubernetes Engine, but you have to ensure that you keep the cost down and performance up. These are the guidelines which needs to be followed when performing task in this lab. So let's start the lab. So once you start the lab, here it will display the zone where you need to create a cluster, and the naming scheme should be this. So they have mentioned the cluster name should be this. So when you are creating a cluster, you ensure that you create a cluster with this name, and whatever you get in your lab, you ensure that you use that name and create a cluster with that name. And the machine size should be E2 standard 2, and cluster should use this rapid release channel. So let's proceed with task 1. Create a cluster and deploy your app. Before you can deploy the application, you will need a cluster in the US West 1 zone and name it as online boutique. So you need to create a cluster with this name in US West 1 zone, and this cluster will have only 2 nodes. And once the cluster is created, we need to create 2 namespace by the name dev and prod. Once the namespace is created, we need to deploy the application to the dev namespace. So they have this sample code here under this GitHub repo. We will be cloning the sample repo. Then we'll deploy this code to the cluster. So let's perform this task. Activate Cloud Shell. Open this in new window. So this is the lab guide. You can refer to this GitHub link. I will be posting this GitHub link under video description. So you can refer to this when you are doing the lab. So here I will be exporting the variables, the cluster name, pool name, maximum replicas, and the zone details and the project ID. So these are very important. So these details you can get it from the lab. So here you find the cluster name, project ID, pool name, max replicas. So and the zone you find it here, US West 1 A zone. So these details you find it in the lab. So let's copy this. Next, in task 1 we'll be creating a cluster to deploy the application. So for that I will be executing this command gcloud container clusters create and the cluster name and where this resource needs to be created. So this project ID is very important because inside project only we can create the resources. So I'll be passing the project ID here and the zone where this resource has to be created. Machine type will be E2 standard and number of nodes will be 2. So these are the configuration which is required in task 1. So I am passing it here. So let's copy this. Now the cluster is created. So once the cluster is created, you will get these details here. So this is a cluster name and the location where it got created and the IP address of this cluster, machine type of this cluster, and this is a node version it's using, and number of nodes is 2, and the status of the cluster is running. So after that we need to create a namespace dev and prod. So let's copy this. Next we need to clone this repository using this git clone. So this is having the sample application and this application will be deploying onto the cluster. So once we clone this, so we'll cd to that repository, then we'll apply kubectl apply and we'll make use of this manifest file. So inside this YAML file we have the configuration written. So we will make use of this YAML file to deploy our application onto this namespace. So here we are specifying the dev namespace. So let me just copy this command. So when you do ls, here you can find this microservices demo, so this folder. So let's cd to this. So when you do ls, here you can find all the files. We will be making use of the YAML file which is present inside this release. So for that, let me do more release Kubernetes manifest YAML. So this is having the deployment configuration. So next I will copy this. kubectl apply, and it will read the manifest.yaml file, and it will deploy all the services which is defined in this YAML file onto this namespace. So here you can find all the services which is getting created. So all this has been defined inside that YAML file. So now we can execute this command kubectl get deployments hyphen hyphen namespace is equal to dev. Since we have deployed all this on dev namespace, so all the services will be available in dev namespace. So you have to ensure that you pass this flag hyphen hyphen namespace dev. So you can see all these deployments here. This is how you see the deployment details, and you can also run kubectl describe deployment and the deployment name. So this is a hat service, and it's deployed in the dev namespace, and when it was created, and if it is having any labels, so it will show all the details and the image it is using and on which port it is running. So all these details you can find it here. Now we have done with this task 1. You can click on check my progress, and you can check that your online Batik store is up and running by navigating to the IP address for your front-end external service hyphen hyphen namespace is equal to dev. So since we have created all the service in namespace dev, we have to ensure that you pass this flag. So this is very important, and this is a front-end external, so we can copy this IP address. So this is what we have deployed it online Batik. So you should get this page. So this is how you verify it. So once that is done, let's proceed with task 2, migrate to an optimized node pool. After successfully deploying the app to the dev namespace, take a look at the node details. So let's verify this. You can go to Kubernetes Engine. So here under Kubernetes Engine, click on clusters. So this is a cluster. Click on nodes here. So this is a cluster which we had created, online Batik cluster 431, and we have 2 nodes running here. So that node details you can find it here, how much CPU requested, how much CPU is allocatable memory requested. So these details you can find it here. There is plenty of leftover RAM from the current deployments, so you should be able to use a node pool with machines that offer less RAM. Most of the deployment that you might consider increasing the replica count of will require only 100 M CPU per additional pod. You could potentially use a node pool with less total CPU if you configure it to use smaller machines. However, you also need to consider how many deployments will need to scale and how much they need to scale by. Create a new node pool named with custom 23584 as the machine type. Set the number of nodes to 2. Once a new node pool is set up, migrate your application's deployment to the new node pool by cordoning off and draining default pool. Delete the default pool once the deployments have safely migrated. In task 2, we'll be creating a new node pool. So we'll be executing this command gcloud container node pools create and the pool name. And the cluster name we need to pass, and the machine type will be this custom 23584, and number of nodes will be 2, and we'll be specifying the zone here. So let's copy this command. So you can set the project ID here. You just need to execute gcloud config set project ID. Now let's execute this again. Now it has created a new node pool. So this is the name of that node pool, and the machine type is this, and disk size in GB is 100. Once a new node pool is set up, migrate your application's deployment to the new node pool by cordoning off and draining default pool. So let's perform this as well. So we'll be executing this for loop. We'll execute this command kubectl get nodes. It will get the default node pools, and it will perform a cordon of all these nodes. So first we will cordon these nodes. Let's copy this. Now both the nodes have been cordoned. So after cordon we will drain this. For this as well we'll be executing this for loop. So it will get all the node pools and it will drain it forcefully. So here we will be executing this command kubectl drain --- force ignore daemon sets, and it will be draining of this default pool. So let's copy this, execute it here. So here we can see all the pods got evicted from this node pool. So next we need to delete this default pool once the deployments have safely migrated. So before that let's check the pod. Let's copy this. So here you can see all these pods are running on this optimized pool. We go back here. Let's refresh this. So under cluster, under nodes, you can find these two node pools, default pool and optimized pool. So this is a node pool which we had created recently. So this is the optimized pool and this is the default pool. I have not yet deleted this default pool. And under nodes, you can find these two nodes are cordoned. And here you can find these node pools are in ready state. So these nodes are part of this optimized pool. And if we check this node has been cordoned and does not accept new pods. But we need to delete this default node pool now. So we'll be deleting this default node pool now. So we have cordoned and drained the default pool. Now we need to delete the default node pool by executing this command gcloud container node pools, the default pool and the cluster name and the project ID. So let's copy this. So now this node pool is deleted. Now we have only one optimized pool. The default pool has been deleted. So even the nodes which were part of that node pool has been deleted. So we just find the optimized node pool and optimized nodes. This is the node pool, optimized pool, and inside that node pool we have two nodes with this name. So now this is done. Now you can click on check my progress. This should be complete. Now let's proceed with task 3, apply front-end update. You just got it all deployed and now the dev team wants you to push a last minute update before the upcoming release. You know this can be done without the need to cause downtime. Set a pod disruption budget for your front-end deployment. Name it online boutique front-end PDP. Set the minimum availability of your deployment to 1. Now you can apply your team's update. They have changed the file used for the home page banner and provided you an updated Docker image. Edit your front-end deployment and change its image to the updated one. While editing your deployment, change the image pull policy to always. So let's perform this. So we are setting up a pod disruption budget for the front-end deployment with this name, and we are setting the minimum availability of the deployment to 1. So for that we are running this kubectl create pod disruption budget and the name we are specifying here. And the selector will be front end. Since we are updating the front end, here we are selecting the front end and the minimum available we are setting it as 1 and the namespace is dev. So let's copy this. Let's execute it here. Now it is created. Next we need to execute this command kubectl patch deployment front end. So we are applying a patch for this front end deployment. And the namespace -n refers to namespace. So here since we have this deployment in dev namespace, we have to specify that. And here we are replacing this. This is the updated Docker image. And while editing, we need to set the image policy to always. So for that you can copy this. Go back to Cloud Shell. Execute it here. So you should get this front end patch message. So after patching the front end deployment, we can verify it by executing this command. So let's copy this. So here you can find the image is updated to this. Click on check my progress. So now this is complete. Now let's proceed with task 4, auto scale from estimated traffic. Here we need to set up the auto scaling. So whenever there is a huge traffic, it should automatically scale up. And when there is no traffic surge, it should automatically scale down. So that we will be setting in task 4. So here we will be setting the horizontal pod auto scaling to the front end deployment to handle the traffic search. So we are setting the CPU percentage of 50. So it will scale as per the CPU percentage, and we are setting the pod scaling between 1 and 11. So let's do that. So we need to execute this command kubectl autoscale deployment, and the deployment name and the CPU percent we are giving it as 50, and the minimum it will be 1, max will be 11. So they have mentioned here. So here they have specified set the deployment to scale between 1 minimum and 11 maximum pods. So that I have defined here. So max replicas you can find. So here under max replicas I have defined it as 11. Let's copy this. So now this is scaled. Now let's execute this command kubectl get HPA. HPA means horizontal pod auto scaling. So let's copy this. So here you can find the front end deployment. It is having minimum pods as 1, maximum pods as 11, replicas is 1. Next, ensure that your cluster is able to automatically spin up additional compute nodes if necessary. However, handling scaling up isn't the only case you can handle with auto scaling. Thinking ahead, you configure both a minimum number of nodes and a maximum number of nodes. This way, the cluster can add nodes when traffic is high and reduce the number of nodes when traffic is low. Update your cluster autoscaler to scale between 1 node minimum and 6 nodes maximum. So let's do this. So for that we need to execute this command gcloud beta container clusters, update the cluster, and the zone we need to specify project ID, enable auto scaling. Under enable auto scaling we will be setting the minimum number of nodes to 1 and maximum number of nodes to 6. So let's copy this. So now this is done. So here we can go to console here. So here you can find the node pool. So here you can find auto scaling is set 1 to 6 nodes per zone. Click on check my progress. So now this is complete. Lastly, run a load test to simulate the traffic search. Fortunately, Online Boutique was designed with built-in load generation. Currently, your dev instance is simulating traffic on the store with 10 concurrent users. In order to better replicate the traffic expected for this event, run the load generation from your load generator pod with a higher number of concurrent users with this command. Replace your front-end external IP with the IP of the front-end external service. So let's copy this. So let's execute this command kubectl get services -n dev, and we need to make use of this IP address front end external. So let's copy this command, go back to this. Here we need to replace this external IP address. So let's copy this. Meanwhile, let's go to this console here. Let's click on workloads. So this is still going on. So we have applied the load and we are monitoring how these services are handling it. So you can see this front end, this deployment, it's bringing up the pods. So now you can see it's 5 of 5. In this lab, we created a cluster and deployed our application, and then we created a node pool to optimize the cost. The existing default pool was having a resource which was not utilized. So we had created a optimized node pool, and we had migrated our pods to this new node pool. Then later we had updated our front end application with a minor change. Then we had seen how to auto scale to manage the traffic surge. Later we had performed load testing on this. So once you complete all the tasks in this lab, you can click on end lab. So after you complete this challenge lab, you will get this optimized cost for Google Kubernetes Engine skill patch. So if you found my video helpful, please like and subscribe to my channel and stay up to date with the latest content on this channel. If you face any issues or difficulties completing any of this task in the lab, you can leave your comments in the comment section. I will be happy to help. Thank you all for watching. See you in the next video.